This is Geometry Unit 8, Lesson 9 on similarity in right triangles. Right triangles have some special rules for similarity and some formulas that we're going to be learning. So let's look at how they work out with the similarity formulas. There's a theorem that says the altitude to the hypotenuse of a right triangle forms three similar triangles. So let's see what we can figure out where the triangles are. So if this is a right triangle, angle C is the right angle. Where are the right angles in these two similar triangles? Well, remember, this is an altitude. An altitude is a height, so an altitude is always perpendicular. So there's the right angle there, and there's the right angle there. So the right angle up here, with a bigger triangle here, this will be angle D. So this is going to correspond to angle A, D, and then C. So it's this triangle right here. Now in the smaller triangle, this would be the right angle right there, would be D. The shorter side that corresponds to C would be B. And the shorter side that corresponds to A would be C. All right, so it's this triangle right here and this triangle right here. So why are these triangles similar? Well, let's see. We know they all have a right angle in them. Well, these two right here, this one and this one, they have angle A in common. So angle A is congruent to angle A. And these two right here, the big triangle and this little triangle here, have angle B in common. So these three triangles are all similar because of angle-angle similarity. Each one has a right angle, and each one shares a common angle with each of the triangles. Okay, so now that we know that, let's see how some of the similarity ratios come out when you're looking at the lengths of the sides. So we are going to label the similar triangles and label each part. Okay, so we have the original triangle, we have the other right triangle, this is triangle ADC, and the smaller triangle up here was triangle CDB. So that's what we have. Okay, now the altitude. This is the altitude in the original triangle. So it is side CD. So side CD is in this triangle right here, it's A, and it's also in this triangle right here is also A. So that is the altitude. That altitude is where that is in each of those triangles. Okay, capital L is the long leg of the original triangle, so the longer leg of the right triangle. So that would be AC here. Well, that would also be AC right there, because this would be the longer leg of that triangle in this picture right here. Okay, the shorter leg of the original triangle would be BC, which would be right there. Now BC is also right here. Okay, then H is the hypotenuse of the original triangle. The hypotenuse of the original triangle is right here. It is side AB. That's H. All right, do I see AB anywhere else? Nope, AB isn't anywhere else over here. Okay, now P, this is vocabulary. Capital P is a projection of the longer leg on the hypotenuse. Projection, I think of it like a shadow. So if you look at the shadow of this leg, the longer leg on the hypotenuse, it would be AD. So that would be capital P. And the projection of the shorter leg on the hypotenuse would be BD, little p, right there. So those are the values I have. So let's look at other triangles. AD here would be a capital P, and DB over here would be little p. So you can see where those triangles get their parts from. Okay, now remember that these triangles are all similar, so their sides will be in proportion. We can find any of these parts, A, L, L, H, or P, by setting up proportions of these similar triangles, and we can look at where they come from. Let's look at the two smaller triangles, ADC and CDB, and see if we can figure out the ratio to find the altitude. Well, if we look at our two triangles that we had here, we can copy it from the beginning. I'll just copy mine here so you can see them. All right, this was triangle ADC. This is the bigger of the two triangles, and this is triangle CDB, which is this one right here. The right angle was up here. All right, now we said AD was capital P, DC was little a, AC is L, and then DC is little a, and little p, and little l. Okay, so there's the sides that we have. If you flip back here, you can see right here, that's the same ones I just drew. It's these two right here. Okay, now, if I want to find the altitude, I want to use the ones that have A in it. Well, I have an A right here. So, A corresponds to little p, and big P corresponds to little a. All right, so setting up your corresponding sides, we have the formula P is to A as A is to P. So if we look in the original triangle where that is, P is to A as A is to P, here's the original triangle. Big P is to A as A is to P. To find the altitude, it is the two pieces of the hypotenuse is a proportion with the altitude. So P is to A as A is to P will give us the altitude if we have those values. So if you have the pieces of the hypotenuse, so if the pieces of the hypotenuse and the altitude, you can find any of those parts. Now, if we look at ACB, which is the big triangle, ACB, here's ACB, and then we had triangle ADC, which is the medium-sized triangle, or the smaller triangle, the bigger of the smaller triangles, I should say. All right, so there's my triangles right there. We had a CB, which was the original triangle, and then we had a DC, which was this triangle right here. So we are looking at these two right here, those two right there that we're looking at. All right, let me put in CD so you know which one I'm talking about. That's CD right there. Okay, so that's CD. All right, so this is the original triangle. This is the bigger of the two smaller triangles. All right, so let's see what we have. H would be this. The longer projection would be capital P there. And the longer leg would be here. Okay, now on our other triangle here, we can copy it right from here. This was P, this was A, and this is capital L. Okay, now notice the hypotenuse of this triangle is coordinating to the hypotenuse of this triangle, but the hypotenuse of this triangle is L. So that's going to be hypotenuse of the big triangle to the longer leg. All right, now the longer leg, which would be right here, corresponds to P, which is right here. So H is to L as L is to capital P. So when you're figuring this out, the hypotenuse to the longer leg is to the longer leg as it is to the projection. So H is to L as L is to P, because this triangle is over here. So H is to L as L is to P. The hypotenuse of the original triangle corresponds to the leg of the smaller triangle. It's the leg of the smaller of this triangle is the hypotenuse of this triangle, is what I'm trying to say. So H is to L as L is to P. All right. Now, one more. We have ACB, the original triangle, and CDB, which is the smaller of the two. So let me draw those here so we have them again. Back in solid. So here's my big triangle. That's this one right here. So I'm going to put my values back on there. And then I have my smaller triangle, which was this one up here. All right, so I have ACB with the right angle here, and my altitude right there. That's D. Okay, so this was L, this is capital P, this is little p, this is A, that's H, and that's little l. Okay, now in this little triangle over here, we had CDB. This was the right angle. We're talking about this triangle right here. So that means we have the hypotenuse of this little triangle. If this is the right angle right there, then the hypotenuse is little l. CD we have is A, and CB is, or BD, I'm sorry, is little p. Okay, so we can also set up the ratio here. We have the hypotenuse of the big triangle corresponds to the hypotenuse of this triangle, which is L. So it's H is to L, little triangle. And then we have the shorter leg here corresponds to P over here. So it's L is to P. So H is to L as L is to P. So these two are basically the same. What we're looking at is the hypotenuse and the leg on one side or the other, and it's the projection of the other side. So hypotenuse is to leg as leg is to projection of the big one, and hypotenuse is to leg as leg is to projection of the little one. So these two are basically the same formula, just on opposite sides of the triangle. So if you want to find a hypotenuse or a leg, you would have to use one of these two formulas. If you want to find an altitude, you would use this formula. So this is the summary of your formulas. If you can memorize this triangle and these formulas, you're all set. So let's put in the values. P and little p are the projections, the pieces of the two hypotenuse. So this is big P, this is little p. A is the altitude. H is the hypotenuse of the whole entire triangle, so that would be H. Big L is the longer leg, and little l is the smaller leg. So if you have all of those values, you can use these formulas. Okay, so when you draw these problems, draw yourself a picture and label what you have, and then figure out which formula you're going to have to use. So draw this original triangle. The altitude of the hypotenuse of a right triangle divides the hypotenuse into segments of lengths 5 and 8. What is the measure of the altitude? So I'm going to draw myself the triangle. Here's my triangle, the original triangle. It's going to be a right triangle. Usually you put the right triangle at the top, right angle at the top. Draw in your altitude. Okay, that's my altitude. If that's my altitude, it divides the hypotenuse into segments of length 5 and 8. So this is the longer segment, this is the smaller segment, so this one would be 8, this one would be 5. And what is the measure of the altitude? So we are looking for A. So if we are looking for A, would it make sense to use either of these formulas that have H, L, and P in them? No. We'd want to use the formula that has A in it. So P is to A as A is to little p. So P is the big segment of the hypotenuse, and little p is the little segment. So this would be big P is 8, is to A as A is to 5. All right, so these are the two pieces. 8 is to A as A is to 5. Cross multiply. A times A, remember, is A squared is equal to 40. 8 times 5, A times A. How do you solve for A? Well, we take the square root of both sides. So A is equal to the square root of 40. So the length of the altitude is the square root of 40. If you want to simplify that, remember it's the square root of 4 times the square root of 10, which is 2 radical 10. Okay, you can leave it as the square root of 40 unless it's asked in simplest radical form, but either one would be fine. So A is equal to the square root of 40, or 2 radical 10. So that's what we have. Once you figure out where your formula is, go from there. Let's try another one. In a right triangle, the hypotenuse measures 18 and one leg measures 8. Find the length of projection of that leg on the hypotenuse. So when we draw this one, here's my triangle. It's a right triangle. I'll put the right angle at the top. The hypotenuse measures 18, and one leg measures 8. Okay, I don't know which leg's the longer one, so I'm just going to make it this one. All right, let me put my altitude in here. Here's my altitude. Okay, now, find the length of the projection of that leg on the hypotenuse. Well, if I'm looking at this leg, I'm looking at this projection right there. That's the projection of the leg. So, would it make sense to use any of the altitude formula? No, we don't have an altitude at all. So we're either going to use one of the H is to L as L is to P formulas. So one of these. It doesn't matter which one because it's just the one with the correct triangle, the same triangle. So let's take a look. So I'm going to use H is to L as L is to P. All right, so H would be 18. L would be the leg, would be 8. L is 8 again, and then P is what we're looking for. Cross multiply, we get 18P is equal to 64. And if you divide by 18, you get P is equal to 3.56. Okay, so that is the basic idea of using these formulas. We'll do these next two in class on the next class period.